First of all, thank you guys so much for having us here, Red Hat here at your conference. I absolutely love coming out to community-oriented conferences, specifically from the Java community perspective. And I want you guys all to think about something. You're the few people who get a chance to come to a conference. If you think of the 10 million professional software developers there are out there, of which there are several million Java developers, you're some of the few, some of the elite who get a chance to come to a conference like this and participate in these kinds of sessions. So I think it's incredibly valuable for what you guys have here in Barcelona, and it's incredibly valuable for someone like myself who comes to speak. So my name is Burr Sutter. I'll be giving you guys kind of the slide deck portion of this presentation, and Rafael is going to be giving us the demonstrations. Now, I want you guys to look at that bottommost link there, the bit.ly serverless Java JBCN. That's how you get access to the slide deck, and you'll want this link right now because there's a ton of other things in the slide deck that you're going to want as soon as you see it, but you're not going to have a chance to make a note of that, right? So you want that link. That gets you access to all the other links. Right, we're going to have to move rather fast. You guys ready? Woo! Woo! Fantastic. We're here to talk about serverless, the coolness of serverless. Let's get started. We represent the Red Hat developer team, so at developers.redhat.com, and as a matter of fact, if you came to our booth earlier, signed up, showed us that you logged in, you got a t-shirt, right? How many people already got the t-shirt? I see some folks there. Fantastic. Well, come by, and there's a few more t-shirts left. You want to pick that up? These are some of the free ebooks we offer at developers.redhat.com. So if you're interested in microservices architecture with something like Drop Wizard or Spring Boot or Wildfly Swarm, or even Vertex on the right-hand side there, we're building reactive microservices. And you can see there's a ton of other great content for you to drill down on these topics. So if you're interested in Istio and the service mesh technology, Christian Posta from our team will be here tomorrow to talk about Istio service mesh. You'll want to see more of that. And then also the FAS tutorial, function as a service tutorial, is what we're talking about here today. Right, so you're going to see all the serverless content in this presentation, but you also can go online and grab everything that you see us working through here. Okay? Edson Yanaga gave this amazing presentation last year and had his book that he did the signing for when we were at JBCNConf last year for Barcelona. So that's that book. Remember that one. And we do have a brand new Istio book. Again, Christian will be here tomorrow. So myself and Christian put this book together for people looking at service mesh technology. And he'll do the deep dive session on Istio. I'll also cover it a little bit in the presentation I'll give tomorrow called 8 Steps to Awesome. So this is one of my favorite quotes. We cannot solve our problems with the same thinking we used when we created them, by a fellow named Albert Einstein. Great quote, because we have this problem within our development community, within enterprise IT overall, information technology. We think as developers, we can kind of check in our code late on a Friday, and hopefully operations has to take care of that code and make it run all throughout their weekend. They're the ones who suffer from our bad code in many cases. So I want us to think about that as developers. Sometimes as developers, we can be fairly arrogant about what we think we can do. After all, we're the creators of the next generation. We're the people who can actually build the digital future because we are the digital creators. But ops has to make it run. And I'm here to tell you, if your stuff doesn't actually run and run well in production, then you've actually done nothing of value. You want to make sure you keep it running. And so we want to eliminate this wall of confusion. You guys have seen this sort of presentation before if you've talked about or seen DevOps. And we want the situation where you just think you can throw it over the wall to go away. Okay? So this is what it might look like in your organization. When you build software of this nature, it might look like this big amorphous blob with this gang of people pushing that blob up the hill, trying to get it out for production and make it ready. And you're looking at that person on the far right over there, and that one I just drew a box around, and who do you think that person is? You're probably thinking that's the ops person if you're a developer, right? I'm here to tell you it's the DBAs. Okay? I don't mean to pick on the DBAs, but it's not your ops person. Who's this person on the top trying to ride this thing, surf this thing? That's your architects, your enterprise architecture people, right? And actually your ops person is the person here on the bottom, being crushed under this weight. So I want you guys to be thinking about this, because what we want is to not have to deal with this software deployment every so many months. This is why we only do a software deployment every 3 months, or every 5 months, or every 8 months. It's because it's painful, and it's hard, and not everyone's working together. And so I want you to think about that. And this is a great quote from one of my friends here, Darth Vader. Don't be too proud of this technological terror you've constructed. Okay? Because software development should look like this, where everybody's working together, pushing in the same direction with a nice, tight, cohesive piece of software that we know we can get over the finish line. Deployment will always be hard, but you can make it easier, okay? And we can make the wall of confusion go away, and dev and ops can work together, working hand in hand to deliver the software together. Okay, one more question, and we'll stop all the preachy stuff and get into the real presentation. But are custom software apps and APIs a key strategic advantage for your organization? I want all of you folks here as software developers, keep in mind, you're the few of the millions of Java developers who are even making it to a conference, even making it to the user group, even making it to their meetup. So you are already the elite people, okay? So ask yourself this question. For the company you work for right now, are they fundamentally about strategic advantage through the apps and APIs that you are creating? Or do they see IT as a cost center that must be streamlined, must be reduced? I'm here to tell you want to work for the former, not the latter. Just keep that one in mind, okay? All right, let's talk serverless. This is the buzzword we're here to talk about right now. This is what the hype is all about. And serverless is actually a misnomer, meaning it's not a word that actually reflects what it really is. Kind of like a microservice isn't really micro in some cases, and it means a lot of different things to different people. Serverless also means there are still servers. It's just that you, as a developer, do not have to manage those servers. That's really the key aspect of it. So the Cloud Native Computing Foundation, the CNCF, the folks who own Kubernetes, have a nice definition that talks about the concept of serverless, and it kind of goes into some detail here. We don't really have to worry about it too much, but you can think the fine-grained deployment model where applications bundled as one or more functions are uploaded to the platform and then executed, scaled, managed, build. You just don't worry about all those things. You basically say, here's my function, please go run it on my behalf. That's kind of the nature of what you see in serverless architecture. And this slide actually is fairly complicated. Again, you'll hopefully have the links to this presentation. But this is where you'll see the history of serverless. And the serverless word did not come from the Amazon folks, like many people think. It actually came from the Iron.io folks. So if you're familiar with Iron.io, it's like a message broker in the sky. It's a cloud-hosted service, if you will, software as a service. And it came out in 2012. So just keep that in mind. The serverless term has been with us for a while. We've been thinking about it for quite some time. It started in the world of backend as a service, where we were doing things like databases, message queues, push notifications, all those different types of services in the cloud environment. And they were serverless from the developer's perspective again, because you just simply called an API and instructed that service to do something without managing any servers or virtual machines or Linux containers or JVMs, and you didn't have to manage those things yourself. All these things here you see are links to what I felt were the actual announcement points where you saw these things come to life. So I encourage you to go check those out. And again, you can see the serverless Java JBCN is the main URL. So let's talk about this little thing called a JavaScript function. Notice right away you see it's function, main, params. That's it. It's parameters in, parameters out, and then the body of business logic in between. There's no XML. There's not even a whole bunch of JSON necessarily. There's not a bunch of YAML. There's not a bunch of other stuff you don't need as a developer. You focus only on your business logic. This one specifically comes from Whisk. All right, that's an open source project we're going to show you here in this presentation, but we'll talk about a few others as well. Okay, you can do the Whisk action update, and then of course you do the Whisk action invoke. That's how you can invoke it to test that function, see if it's kind of what you want, and you can kind of see the response from it. And then, of course, you can also get the logs from it, those console.logs. Also, here's the Python version of it. Same thing, same business logic, does the exact same thing that JavaScript did, but here's the Python version of it. And then same kind of process you go through, same steps, update, invoke, activation. And then we can show you this now. So Rafael is going to give us a demo of what this looks like.
Yeah, so it's time now for us to see Whisk working. By the way, let me know a little bit more about you. How many of you have tried serverless before? Some kind of serverless functions?
It's really dark.
Yeah.
There's a
but I can
right
see that there are a dozen who have raised their hands. And what I will show you is a project called Whisk from Apache. Let me show you the website, openwhisk.apache.org. And I have deployed this Whisk inside OpenShift, which is based on Kubernetes. So to manage your functions using Whisk, there is a command called WSK. So with WSK, you can, for example, come here, do WSK action list, for example. That will bring us a list of existing actions that you can call. For example, you can see here that there is a function called samples greeting. if I that's implemented using Node.js in this case. If I want to take a look on this specific function, I can come here, WSK action get the name of function, and that will describe in a JSON format what's your function about. So it says returns a friendly greeting. Here you can see a sample output. So it will say sample output, hello cat from Narrowsburg. A sample input, you send the value of some parameters here, the payload and the place. You can see the list of the existing parameters that are that may be required or not. So in this case, it's a name and a place, and the limits of it. So let's invoke that function so you can have an idea how that works, okay? So to invoke a function, I do action invoke. I don't need to use any parameter here. And in this case, it returned me an ID. This ID allows me to get the result later with the using WSK activation get and the ID of the invocation -- result. Oops. -r. No.
Well, the result's already in the activation.
Yeah. So let me get the result here, and we can see the result. Hello, stranger from somewhere. Of course, I can specify on the invoke method on the invoke command the -- result to get the result. But I can also specify parameters for that function. For example, param name Rafael, and the param place JBCN. And we can get the result from the invocation. And here it says, hello, Rafael from JBCN. But this is a sample that comes with OpenWhisk. But let me show to you how to create and invoke existing functions. And not existing functions, functions that we have defined here. So as you see in the slides, there is a message action using JavaScript. It's the same one that you have in the slides. Very straightforward. You receive parameters, you return the payload. So to create an action, WSK action, create. You give the name for that action, message action, MSG action, and the name of the file. Then you have created action, MSG action. Let's invoke. WSK action, invoke, message action, -- result. I need some parameters. Let me get the parameters here from the slide. And we can see here, JavaScript on OpenWhisk on OpenShift. Now, let's replace that function by the Python implementation. I have here the Python implementation as well, right? Very straightforward, same thing. It receives parameters, it returns a payload, but in this case, it says Python on OpenWhisk. So in this case, let's do an update on this function and replace the name of the file by a Python implementation. I can use the same call again. It will take a time to execute that function, but you see that the same parameter that I used get the result from the function. So that's one thing very important. You can implement your function just worrying about the specific language that you need to solve that specific problem, and have a a very well-defined API where you send parameters and it gets the output. Okay. What about Java? We are here at JBCN. So Java allows us to build functions very easily through the usage of a specific maven archetype. There is a maven archetype for it that comes from Apache, Open Whisk Java. The name of the artifact is Java Action Archetype. So I can invoke that archetype creation. Let me execute that. That will create a Java project to me here called Action Java. There's a POM XML that if I need to package that thing, is just do a maven clean package. That will generate a jar file, of course, but to create a function, in this case, where I used to have just action, update, message action, now, since it's Java, I need to specify some other parameters here. I need to specify my jar and my main class with -- main, the name of the main class in this case. I have updated my function. Let's invoke it again using the same invocation command. And you can see, greetings, hello, welcome to Open Whisk. Of course, there are some situations where you need to expose that function to a web endpoint. So let's get that same action and say that I want to expose that as a web function. -- web equals true. In this case, I can get the action, WSK action get message action -- URL. That will return the URL for that specific function. And if I open that URL, we should see the output. So we are proceed. Connection is not private, I know. Let me curl this URL. Curl -k because of the private certificate. Oh, I know what's. In this case, I have to specify .json. Yeah, I don't know why, but it needs to. And then we can see the result of the function being executed. Okay. Something that's also interesting to know about serverless. Let me open here my Minishift console, so you can see how my functions are deployed, created, and managed by containers. You can see here that OpenWhisk, since it's deployed on OpenShift /Kubernetes, I have several pods running. But I will do a filter here. I just want to see all those pods that are active. At this moment, there's no active pod. But if I invoke an action here, let me invoke. Sometimes it's very quick. Let me use another function here. Let me use the Python one. Update. Python. Invoke. It's very fast. I wanted to show.
Because it's not the status. Make the status.
Yeah, status and active. Oops. Filter. Oh, there you go. You can see that the pod was created, it executes the function, and then it dies. So I can invoke several times. And you can see that the pod's created, and then it's not active anymore. That's why it's called serverless. Okay.
Okay, but that's actually a very important point what you guys just saw there. The pods, the Kubernetes pods, OpenShift in our case, right? That's Red Hat's supported distribution of Kubernetes. It's basically launching those pods in response to the need, right? The demand at the moment when that function was invoked. You can also pre-warm these pods, meaning they can kind of be living out there in a pool, if you will. You can also determine how long a function can last or how long it can run. So a little bit different, let's say, than the Amazon Lambda world, where the Amazon vendor determines exactly how big it can be, how long it can run, and what it can do. In this case, you have vastly more control by running this, let's say, on-prem in your own data center, where you have control of those same parameters. So let's kind of talk you through exactly what the difference is between microservices versus serverless functions, because I imagine that's a big question in everyone's head right now. Where would I use this versus the other thing? And the microservices are pretty straightforward. We kind of know the programming model of microservices. We've been doing it now for several years. As a matter of fact, for people who have moved to microservice from their monolithic architecture, you might have just dragged and dropped your code from one architecture to the other, because it still uses JAX-RS, it still uses Spring MVC, it still uses Spring DI or CDI, JPA. All those same APIs are the same in the monolithic Java EE world or the Spring Boot microservice world, or depending on where you're going. So that's one thing that's super nice about the microservices architecture. It's easy to learn from the perspective of what your code looks like. You have full control of the life cycle of that component. You determine when the JVM starts, and you determine when the JVM shuts down. You have control of that. That's what your role is when you build that architecture and build that application. You also have a very well-known programming model with the traditional request-response programming model. In other words, it's still a REST endpoint where you get, put, post, or delete, and you know exactly when that gets triggered, how it gets executed, what happens when it's executing, and then the response you're getting back. So the nice thing about microservices is it's easy to learn the programming model aside from the distributed computing aspects of microservices, right? That's really where you get burned, is when A calls B, calls C, calls D. But otherwise, everything's the same. So if you think of it from this perspective, a microservice is wonderful for listening to a socket with a thread pool on a long-lived kind of process, where I want a WebSocket that's connecting to me. I want to watch all these transactions streaming in. I want to keep that process always on and always up. So if I'm building a message broker, that's more of the traditional architecture. But if I'm building business logic, it just has to respond to certain user interface events or certain kind of events coming from a third-party system. Maybe it's a function. So on the other side of this, you basically have less control of what your function lifecycle looks like. It's under the cloud control. The cloud determines when it starts and when it stops. You as a programmer don't have control over that per se. It determines exactly how long it can run. Can it run for 2 seconds, or can it run for 20 seconds? Can it run for 5 minutes? The cloud controls that in the serverless world. You have this new programming model, which you just saw a taste of. We'll show you a little bit more complicated examples in a minute. But the programming model is very different. It looks very different than what you're used to. There's not so much JAX-RS and JPA kind of stuff in there at this point. And then it's event-driven async all the time. Okay? You can make it request response, as you saw us here in this little example, but by default, it's always async, always event-driven. And you have to think through exactly what events can be pushed into your function. That's really going to be the secret sauce of function as a service engines, is he or she who has the most events will probably win this war. One thing you got to keep in mind with all the serverless architecture right now, it is all up for grabs. It is complete full-on warfare across dozens of open source projects in the community. We don't yet know who's going to win in this ecosystem. Okay, there's going to be numerous projects that just become abandoned over time. We'll have to see how that plays out. In the case of microservices, though, you'll see right here where I say it's very mature. It's mature because you know what your IDE has to look like. You know how to integrate your IntelliJ, your NetBeans, your Eclipse, your VI, your Emacs. You know how to set that up. You know how to run your debugger. You know how to do tracing and monitoring and continuous integration, continuous delivery. We know how to do all those things. We know how to do blue-green deployments of microservices and canary deployments. Those are all things that are fairly well known to us. But on the function side, we just don't know yet. Right? There's some people who've said, okay, here's how you do debugging, but it only works with this implementation for that implementation. Here's how you do tracing, but it only works with this extra service. Like there's a lot of third-party services now offering tracing for Amazon Lambda as an example. You know, we don't really know how to do CI/CD deployments and things of that nature. We don't necessarily know how to build the immutable image that pushes through the pipeline on the function side of the house. That's because it's all very new, and we're still learning all these things. And so we're working on several of these things at Red Hat to basically extend, let's say, the OpenWhisk capability to give you those kind of capabilities for your functions also. Full pipeline, full debugging, tracing, monitoring, et cetera, but it's still immature. All right? So this by itself, this chart right here might be the way you decide which path you go down. Do I want the more mature path of something well known for my development team? Because many of you here represent the lead. You're the lead for your development team, right? You're the architect for your development team. There's another 25 people back at the office who weren't allowed to come to this conference as an example. So you'll have to make these kind of decisions about your architecture. Do we do serverless here or do we microservices there? All right? Now, this is another version of that same slide, but it's the good and the bad, right? You get automatic scalability, you get automatic cost reduction. It's certainly easier and faster to build functions versus, let's say, microservices. You can also do better capacity planning because all you have to do is kind of load test and figure out exactly what you need from a capacity standpoint. And so it's nice, but you lose the debugging, you lose the nice CI/CD, you get some vendor lock-in over there. And that's actually the biggest challenge we see with serverless architecture right now. If you build functions on a certain cloud platform or another, you are locked into that cloud platform from this point forward. That might be good. That might be what you want. It might give you might trade off that additional productivity, that additional power for that lock-in. But for some of you, you're going to think, I don't really want to be locked in. And what we're showing you right now with this technology is not only running on this laptop and can run on your laptop, it can run on any cloud provider you take it to. So we actually showed a big demonstration of the same thing back a couple weeks ago, where we ran it on all clouds simultaneously. All the code was fully portable across all cloud providers. So that's the real big win with this architecture versus, let's say, a specific cloud architecture in the case of serverless. Okay? All right. So the first question you have to ask yourself when you're looking at architecting applications this way, is there a suitable service I can just use in a buy versus build mentality, right? So you're making the decision, can I buy it or do I have to build it? And you should be thinking about that in all cases. I've run into way too many teams who've built their own message brokers. Well, guess what? There's like a dozen of those in open source that are pretty awesome. You don't have to build a message broker. Okay, so you guys are thinking, well, my people have never built a message broker. I guarantee you, in a room this size with the hundreds of you we have here right now, somebody has built their own MVC framework, right? Okay, don't have to giggle too much, people, and don't nudge the person beside you. But you know, you've worked for the organizations that had to build their own model view controller framework. They couldn't use one of the dozen or so that are out there already. And if it wasn't that, on the server side, someone had to build their own JavaScript framework for the same thing. So this happens time and time again. And the real point of serverless, the reason it's magical and makes you vastly more productive is because you stop building everything and you start just using what exists as much as possible. It's a different, and you're not going to worry about the MVC framework in this case, but you're going to think in terms of, is there a caching service I can just use? A message broker I can just use? A database service I can just use? As opposed to, let me see if I can write one of those myself. I recognize many of us here are cool software engineers, and we want to rebuild our own database engine all the time, but at some point, you got to solve your business problem and not focus on building these services that you don't need. So it's serverless because of SaaS. It's serverless because of SaaS, software as a service providers that are managed by third parties. So it's all about the services. Like in this case, the HTTP input and output, right? Think of all those get, put, post, and deletes. That's what we call API gateway as a service. And you're probably going to want one of those to basically have your HTTP traffic come in and out of your service. You might want an SSO service, meaning we want single sign-on of some sort with OAuth connectivity. Maybe it handles social login, things of that nature. Red Hat has a project we sponsor called Keycloak that does exactly that. But you might want some form of SSO as a service. How about storage as a service? For all those binary objects that exist within your application, let's say you're in the insurance business and you upload PDFs for claims and PDFs for contracts. Maybe you're in the mortgage business. You have all these PDF files. You have all these JPEGs, these videos and things of that nature. Perhaps you want to have those available to you and some nice storage or CDN, right? Content Delivery Network. You might have some form of caching mechanism, and you might have some form of database mechanism. You probably do have some persistence model where you keep your data. But think of these things as a service now going forward. And you want to create the same thing for yourselves in your private data centers, even if you're not ready to move to the public cloud at this point. Yes, you can do these same things, let's say at Amazon or Azure or Google, but what if you could do this wholly on-prem as well? And people are now starting to move in this direction. I want a messaging as a service. I want a message broker as a service. I don't want to have to recreate that. I want to just consume it. How about notifications? So if something changes within my architecture, can I send a notification back out to my user, right? Think of that as a push notification if you're on iPhone or Android, or it might just be the desktop browser notifications you see now built into the browser architecture. But all these things are possible. And then you would add your custom business logic, your long-running processes as microservices. So you'd still have microservices in your architecture. And then you might have functions in your architecture, okay? So event-driven input and event-driven output. So just that's how I see the future moving, right? So we're going to be thinking in terms of all these things. Where can we just build a function to solve the problem versus a whole microservice? Here's a great example. Most of you probably have built some form of batch or cron job for the nature of your architecture, right? Think of any cron job as a function in this system. That's the simplest way to get started, right? Replace any cron jobs with functions. Basically, you can set up a function. We didn't show you it here, but it's super simple to basically put a function on a cron cycle and let it run whenever it's supposed to run. And that might be the fastest way to get started with functions doing something at intervals, as an example, okay? And then, of course, you can consume these from your business-to-business transactions, from your mobile desktop, from your mobile application, okay? I like this quote from this guy named Thor. And technically, he didn't add the word computer in there, but that's okay. Our ancestors called it magic, but you call it science. I come from a land where they're one and the same. I mentioned earlier in this conversation that we are the digital creators. We are the people who truly have a superpower to build things that the rest of the world need. To put that in perspective, there's only a handful of people, if you will, in this room, of the multiple millions of Java programmers and Java developers, professional developers around the world, and we all have to write services and capabilities for the other 7 billion people on this planet. The ratio is way off, and we've got a lot of work to do. But all of those billions of other people, they look to us as superheroes, if you think about it. We're the only ones who can make the stuff that they need around their smartphones, their web pages, their back-end business transactions. In other words, when they put money in the bank, they assume the money's going to stay in the bank, right? So we get a chance to do that. So that's why I like that quote. So here are all the big players you see in the Kubernetes world of serverless. So you see like Kubeless there, you see Apache OpenWhisk, which is a project Red Hat is behind right now. Function, so the FN project, that's the Oracle team. So Team Oracle is FN project, that's what you see that fin there. The lower right-hand corner is Riff, that's Team Pivotal. They're behind the Riff project, and they're making that work also. You see OpenFaz, which is right now just a small team of people working OpenFaz and Fission, and there's probably another dozen that I didn't find the logos for to put here. So you're going to see consolidation in this space. And I mentioned Pivotal, I mentioned Oracle, I mentioned Red Hat. IBM and Red Hat are partnered on OpenWhisk. Kubeless and OpenFaz. OpenFaz, I think, is VMware now at this point. But there's one player who's not really announced what they're going to be doing. So just keep in mind, you're going to be watching out for what Google decides they want to do. Okay? So that could change the game entirely based on what Google launches into the space. But right now, these are the kind of the big players in the function as a service, open source world running on top of Kubernetes. This chart is actually very important for you to understand exactly how the platform enables you to build applications. If you look at a traditional on-premise data center model, I don't know if you've ever had to do this as a developer, but if you've ever had to wait for, let's say, new hardware to be racked in your data center, it takes some time, right? Hopefully you have the rack capacity, but if you don't, and you have to add a new rack, that can be very problematic because you don't have the floor space, and then you don't have the ability to run the wires that you need there, and then you got to get enough power and air conditioning for that room, and then you got to get the rack installed, and then of course you got to put your 1U rack-mounted servers in there along with the UPSs and like APC, basically uninterruptible power supplies. Wow, it's a hard word to say. But basically, you got to get all that set up. And actually, we did this at Red Hat Summit a couple weeks ago. We actually built an on-stage rack, full, it was about 7 feet tall, a full rack on stage to show a whole data center that we could have there. And so you do that in your on-premise data center today. You have to set up all that hardware and infrastructure. And so that's why you see on the left-hand side of this chart, okay, all of that. So you're responsible for not only the hardware and the network connectivity, the power, and the air conditioning, but also the concept of the operating system and the applications which run on those operating systems. As you move further to the right, some of those things just move away from you. If in the case of infrastructure as a service, right, you give the power and the air conditioning and the actual physical servers over to Amazon as an example. You don't worry about that anymore, okay? But when you get all the way to the far right, here with the function as a service, all you worry about is your business logic. You just simply say, here's my business logic. I care not at all about your air conditioning bill. I care not at all about your footprint. I don't care at all about those virtual machines. And I don't care at all about those containers, right? So even the container goes away when it comes to a function. Okay? Apache OpenWhisk here. God bless you, sir. Apache OpenWhisk here basically supports things like JavaScript, Swift, Java, Python. You saw Python, Java, and JavaScript earlier. You can also just use a whole Docker image to get that to fire based on the function invocation. And it's deployable anywhere you can pretty much run this set of capabilities, and we run it on Kubernetes or OpenShift ourselves. These are the terms you saw earlier. So the concept of function is called an action in the case of OpenWhisk, so they refer to it as an action. But you'll also see some other things, like the package, which is a bundle, and then feeds. Feeds represent the input to the system, the integration from, let's say, different event sources into the system. You also have this concept of a trigger, which is what causes that event to fire, right? Like a specific input or output, or a specific get, put, post, or delete, or maybe the cron interval is when that trigger fires, okay? You have the concept of rule, you have the concept of an activation. You saw that in the demonstration earlier. Basically, these things get invoked. They all get invoked asynchronously, and you can use the activation to find the logs, to find the output, and figure out exactly what happened in the history of all those invocations. So again, purely async from that perspective, okay? You saw the Maven archetype as well already, and then Rafael showed you basically running this all within the console and things of that nature. So you guys got a chance to see all that already. But we're now going to show you kind of the hardcore demo, so you can kind of see more of an interesting application where it's actually built using functions. Okay, Rafael?
Okay, you have seen that I used a simple function, invoke it, and that's it. But let's go through an integration scenario. What I have here in my OpenShift is, oops, let's go back here to where you belong. I have a Apache Artemis running on this server. Apache Artemis is a message broker. So what I will do now is send a message. I will post a message on a queue of Apache Artemis, and then that message will be fed. It will be input in the message. It will be consumed by the message using the feeds. You saw here. One of these terms here is feeds. Feeds acts as an interface between external event source, in this case Apache Artemis, and OpenWhisk action. So, and then that feed will trigger some functions based on an existing rule. The rule ties existing trigger to existing actions and vice versa. So in this scenario here, I have a couple of different functions. I have a function written in Python that will split a collection of strings that I will send. Then I have another function here written in Go that will sort those strings. I have a Java function that will turn them in an uppercase. And then a JavaScript function will post back the result on Apache Artemis. So let's take a look on some of these functions. You can see here, it's the same case, same usage, if you know what I mean. I get an action, an argument, I split them and post, and I forward the parameter result to another function that will be called later. In this case, the upper function that's written in Java. The function app that's written in Java will get the argument, the result from the previous function, turn them in an uppercase, and then forward the reply to result. And then it continues through the sort action, and finally the message action that will post back the message to the broker based on the broker host and the broker port. Let's take a look here on my package. To all those functions I previously deployed inside a package makes it easy to group those functions. So I can use here WSK package list to get the list of the existing actions. I have here the message demo, so let's get that function, that package get message demo. Note here that all the previous functions that I talked are already deployed. The message sender using Node.js, the sorter that uses black box means that it's executing a native compiled Go sorter. Uppercase uses Java, splitter uses Python. And there's something that's very important here also. I can use for all functions a collection of parameters. So these parameters that you see here will be consumed by all functions. It's available to all functions inside this package because this parameter is related to the package and is passed to the function automatically. So what I will do here first is to create a trigger, which means that everything that I post on that message will needs to come from a place. In this case, I have AMQP trigger. So you can see here that this trigger that I given a name trigger Q99 will based on the AMQP feed with the following parameters. The queue that I'm listening is the Q99, and the connection options are the Apache RTM is host and port. That creates the trigger. Okay, now that I have the trigger, I need to create one single action in sequence that will be invoked. So I showed that that package has all the 4 different functions. But I can create one single function that is based on a sequence of functions. Let me get down here. Oops. Trigger. Message broker, message functions, trigger, yeah, action update. So here I'm creating, oh, I'm having troubles with the, okay. Here I'm creating an action called split sort UCase that will invoke those functions in sequence. It will invoke the splitter, the uppercase, the sorter, and the sender that will post on the result on the broker. And finally, I can create a rule that says everything that comes to that that is fired through that trigger, you will call the following function. Okay, so that's the glue between the trigger, the rule, and the actions. Now, I can go to my test case and listen for a specific, this is a node application that listens to a specific queue on the message broker. So I'll wait here, listen here for the queue reply JBCN. So every message that goes, that's posted on that queue, we'll see here. Let me keep here also WSK activation poll, so we can see the list of activations. And finally, I can call a function. I can call an application that will post some string on a queue, the Q99, where my application is listening. I will say here, I will give the following parameters. The reply to JBCN, and I can give here a list of strings. So let's place here Rafael, Burr, Red Hat, what else? JBCN, what else? Barcelona. That's enough. So let's trigger that. Message accepted by peer. Oops. And we saw here the demo result. All those strings were splitted, ordered, and turned into uppercase. So let me do again activation poll. It was too fast. Yeah, you can see here. Even if I go to my my OpenShift and go to the list of pods, let's do that same thing again. I want to see just those pods that are active. Let's invoke. You can see that all the functions, the 4 functions are invoked, the message is posted, and we have the result. So this is a great example of integration scenarios where the function is listening to a kill. You can create a chain of actions and then consume the result from that specific kill again. Okay?
Yeah, so this diagram you see here is exactly what we just showed you in that particular demonstration. So you can kind of see it went from ActiveMQ, it went in and basically was processed by all those different functions and came back to ActiveMQ. So this is the kind of style of application architecture or the style of programming you'll use in this function as a service world, this serverless world. And you'll have to decide, okay, is that something I want to go do? Is that appropriate for our system? So I'll actually quickly mention, before we run out of time, we did a demonstration just a couple weeks ago at Vox Day Singapore, as well as a Red Hat Summit, where we actually showed a single application built with both microservices and functions. So the microservice basically held a real-time connection to everyone's phone. So a WebSocket, a bidirectional WebSocket connection to every phone so that we could have real-time communications. But as you uploaded photos from your phone, we would take that file and drop it into a file system up in the cloud. And we had functions waiting for those files that would pick it up and then run the TensorFlow-based YOLO against it, basically scoring the object, looking for certain things within it, because we might be looking for a teddy bear, we might have been looking for a horse, might be looking for a computer, and it would provide a score, and we'd send that score back out to our waiting user. So it was a really nice example of having functions where we were using it to do the AI ML stuff, and basically the business logic of the application, but the microservice was the person responsible or the component responsible for holding open that connection constantly with that waiting user. And then we had another microservice that was basically updating a dashboard in real time, so you actually saw all these transactions flowing through the system, but so functions and microservices working together. That whole demo has been open sourced also. If anyone wants it, you can kind of watch it on YouTube, or I can tell you where the GitHub repos are. But next. Okay, this is an important point that we want to make sure we talk about. The key to all the serverless architecture is going to be who has the most events, input streams, the feeds that we mentioned here earlier. So OpenWhisk has a number of them already out of the box. The various players in the industry are working on this as well. But this is going to be what makes your application more portable and more powerful, as the concept of having what the event streams are defined. So there's a group of people out there called Cloud Events.io, that's already trying to work on that. And just a few weeks ago, they did an interop event where they actually showed that multiple function as a service providers could actually listen to the same event, exact same event, and receive that event through their system. So this is often a common question people have is, well, how do I actually ensure that my system, my function as a service engine is working well with the event, the overall ecosystem? Cloud Events.io is one of the primary things you want to be checking out. So all this is, again, very new, but you can follow it very closely there. And we're basically kind of wrapped up here. Actually, go to the last page there. And again, you can get the link to the, the other last page. Yes. There you get the link to the presentation there. You can get access to myself and Rafael. We do have 1 or 2 moments, though, for a couple questions. And I think there was a microphone you set up, or there was? All right, fantastic. Nope, got to turn them on first. Is there anyone with a question, though? Even if it's just like, Rafael, how old are you? How about that? It could be something as simple as that. We can't see you, though, very well. It's kind of bright from down here. There's no question? Oh, wow. Come on. You want to know how old he is? He's actually a nice 24-year-old young man like he is. What's that?
Questions as a function.
Questions as a function. That's what we need. Okay. Well, if there are no questions, wait, I can't even see.
Something that you guys need to put emphasis on is what the benefits that platforms like OpenShift and Kubernetes has eased the usage of this serverless application, because you can run out of resources relatively easy without having to take care of how to provision the services or how to provision the functions themselves. I mean, what's your thought about it?
Okay, so if I understand your question or your point, the beauty of running these things on a Kubernetes-based architecture, right, or an OpenShift Kubernetes-based architecture, is that it's taking care of all the scale out and scale in for you. So if we had 15 computing nodes in this system, which we only have one on this laptop right now, but let's say we had 15 servers, it would take care of scheduling those function invocations around those 15 servers on our behalf. And of course, we can have specialized we get a very specialized footprint for that, right? How many cores it needs, how much memory it needs, and then it would put it on the machine that's least loaded as well. So that's the nice thing about running it on a Kubernetes-based architecture. If that kind of addresses your point? Yep, cool. So that's something that we're very excited about, and that's why we're investing in it very heavily at Red Hat, because we are very invested in Kubernetes overall. We're the second largest contributor to Kubernetes. And again, our enterprise distribution, that is OpenShift, but we're very much focused on making this new type of application architecture possible for the customers that we have running within the OpenShift ecosystem. And we are officially out of time.
Yep.
All right. Well, thank you so much. Rafael and I will be available at the booth if you have any other questions or just want to come hang out with us or get that T-shirt that some of you guys already picked up. But feel free to hang out with us on Twitter, send us an email, and don't forget the slides, because that's the next question someone has is, what was the URL to the slides again? It's right there. All right. Thank you guys so much.
Thank you.